So here's your homework for inverse trigonometry. And so one thing we learned is that instead of using a little -1, sometimes we use the word arc instead, which means the same as inverse trigonometry. So this means inverse cosine. So arc cosine -√3/2. By memory, you have to know your unit circle. So the first thing I need to know is what quadrant we're in. So for arc cosine, that's negative, we have to know we're in quadrant number 2. The next thing we need to know is, if it's cosine, that means the x-coordinate is √3/2. That's Batman. So Robin has to be 1/2. And can I put this together to understand what is the angle there? So I know, working backwards, this is a 30-degree reference angle. Then I know the answer must be with a 6 in the denominator for radian. Now you could write this in radians or in degrees. Good to know both. So if it was in degrees in quadrant 2, 30-degree reference angle, what's 180 take away 30? The answer would be 150. In radians, what would it be? Knowing your unit circle, and it would be 5 pi over 6. The inverse tangent of +1. So if I'm dealing with that, I need to know, first of all, because inverse tangent's positive, we're in quadrant number 1. So whenever we have a positive number, we know we're in quadrant 1. I need to know what point. So the rule for tangent is y divided by x. So which point, when I go y divided by x, gives me the answer 1? And that's √2/2. So √2/2 and √2/2 give me that answer. So what angle then goes with that? And the answer is pi/4, or you could write down 45 degrees. Arc sine -√2/2. So understand that when sine is negative, we're in quadrant 4, but we're going to write it as a negative angle in quadrant number 4. So first of all, understand the reference angle. So if the y-coordinate is √2/2, which is that reference angle? Oops, and the answer is 45 degrees. Now the easy answer here is you could just take the reference angle, and the answer is -45. And if you want to write it in radians, it would be -pi/4. They're equivalent. So I just take the answer and write it as a negative angle in quadrant 4. Again, inverse sine. So I know it's in quadrant 4. I need to know the y-coordinate. So if the y-coordinate's -1/2, that means the x-coordinate must be √3/2. What's the reference angle here? And it's 30 degrees. And I write it as a negative angle. So the answer would be -30, or you could write it in radians, which is -pi/6. Number 5, arc cosine 2. 2 is beyond the value it could be. For arc, cosine, and sine inverse, the numbers must be between -1 and +1. So this does not exist, or it's undefined. Tangent doesn't have any restrictions. It can be any number inside here. So arc tangent -√3, that's good. I know we're in quadrant 4. I know I'm going to write it as a negative angle. So now what's the definition? So it's y divided by x. So which point when I divide y divided by x will give me what I need? So I know it's going to be over 2 because they're all over 2. And the question is it √2 and √2? No. It's √3/2 and 1/2, but what order? So if I'm going to divide, the y-coordinate must be √3 and the x-coordinate must be 1. So when you go y divided by x, it gives me that answer. So what's the reference angle here? That's the answer you put in here. So the reference angle is 60 degrees, so it's -60, or you can write it in radians, -pi/3. Inverse sine 1/2, we're now in quadrant 1. We know the y-coordinate's 1/2. I know the rule. So the partner that goes with it is √3/2. What's the reference angle? That's the answer. So the reference angle that goes with this point, working backwards, is 30 degrees, or you can write it in radians, which is pi/6. Last one here, practicing just evaluating inverse tangent or inverse functions. So arctan of negative root 3 over 3. So I know the answer is going to be a negative angle for arctangent negative root 3 over 3. I need to know the rule, which is y divided by x. I know there's going to be a 2 in the denominator because all of those have a 2 in the denominator. But what would it be? Is it going to be root 3 first and then 1 or vice versa? So I have to have an understanding that when I go y over x and I rationalize it, that's going to be the answer. And the reference angle for this is 30 degrees, or you can write it in radians. All right, number 9. Molly is looking up at the St. Louis Arch. And it stands really tall, 630 feet tall. The angle of elevation from her line of sight. So here's Molly, and she's looking at the arch. And it says to the top of the monument. Oh, you're going to fail me now. Try a different pen. Where's my pen? Here's a pen. Okay, so I'm going to create a right triangle here to the top. What I do know is the height of that is 630 feet. And it says the distance she is from the arch, I don't know. So I'm just going to generically call that D. And then I have an angle from the ground to the top of that arch. Using this diagram, write a function for theta in terms of that. So a function for theta so it's opposite over adjacent, so it's going to be tan. And this is what the angle is going to equal to. So written as a function, this is what it would look like, but really you're finding the angle whenever you use inverse tangent. You could also go tan to the negative 1. And then it's opposite over adjacent. Oh, and she says there's another part to it, that her eyes are 5 feet 3 inches, just for no fun at all. So because of that, it's not going to be 630. You're going to subtract from the ground up 5 feet 3 inches. There's 12 inches in a foot. So that's 3/12, which is a quarter. So that's 0.25. So for no fun at all, 5.25 I have to subtract. So if I do that subtracting, it's 624.75. So that's the number that needs to be in here. And that's over D. 10. A boat leaves the dock and travels 172 meters before dropping the anchor. The angle of depression depends on D, the straight line distance between the end of the dock and the anchor. So we have a dock. We have like where the boat goes to and then drops the anchor here. And it's the angle made with the horizontal. So if you think of it going below the water, that's the actual angle for the angle of depression looking down at it. So it's in the triangle in this situation. And so I need a function for the angle. So if I want to find the angle, I'm going to write it as a function. Again, what do I need? So D so the straight line distance here from the dock to where the anchor is. So the D is going to be the hypotenuse. So 172 is adjacent and hypotenuse. SOHCAHTOA. So it's going to be inverse cosine. You can go arc or to the negative 1. And then what goes inside is adjacent over hypotenuse. And that's it. Now, if you use your calculator to find the angle, when the straight line distance is 205, then I'm just going to use my calculator and make sure it's in degrees when I do it. So if it's not in degrees, it'll give you a weird looking answer. So in degrees, what will that angle be at 205 meters? So I'm going to change mine to degrees. And then I'm going to go inverse cosine 172 over 205 and then round it. Oops, try that again. So I get 32.963 degrees. Number 11. The radar on a ship picks up two shipwrecks, A and B. Here are my shipwrecks. 2.5 miles beneath the surface. Might as well fill in the triangle as I go on. The distance between the shipwrecks is 0.6. The angle of depression to the shipwreck B, so I need to draw this one, it's this angle right here, depends on the horizontal distance from the ship to shipwreck A. So this is the horizontal distance to shipwreck A. It says write a function for theta. So theta would be depending on D, that horizontal distance. Again, you can use arc or you can use inverse. So in this case, I don't know the hypotenuse at all. So it's going to be tangent. I'll go back and forth so you're comfortable with both. And then when I think of that, that angle that's outside the triangle will end up being inside the triangle here. You can use like a Z pattern with parallel lines. And if I want to know that angle in terms of the opposite is 2.5. And adjacent to that is D plus 0.6. And that's it. So then use that function to evaluate at 1.4. And then you just use your calculator. So again, you're finding the angle. And 51.340 is what I get. All right, turn the page. Oh, that's it. So there's your homework. Good job, Mr. G Math. Over now.